Hi Josh, this is Professor Sebastian here trying to give you some feedback about your Precalc exam 2. Also let you know a little bit about how you're doing in the course and talk about the final. So let me do that real quick. So before I reviewed your exam, you had a score of 48.33%. After I reviewed your exam, you had a score of 65.7%. All right, your total not GPA, your total percentage grade right now in the course is 74.31, and if you look at your MyStatLab gradebook, which I don't want to pull up here because I have to show you other students, but you have 74.31%, which matches your Canvas gradebook because I always want those to match, and I constantly check that. But so just make sure that you're keeping up with the material and you're getting everything done because you're well on your way to doing fine. We just got to get you through this, okay? One thing I do notice, your grade would go up a little bit if you have some missing notes here that you didn't send me in a while. So you're missing these notes, and I'll certainly still take them if you have them. Just make sure you get them to me, okay? So take a look at what notes you're missing and make sure you get those to me. And as far as for the final, the first 50% of the final will come from the exams 1 and 2. So study exams 1 and 2. Use my feedback, make sure you know how to do all those problems. And then the second 50% of the final, 25% will come from the quiz from week 5, so quiz 5, and the other 25% will come from the 2 homework assignments that are coming up here in week 6. So it's backloaded, 50% is on this third part of the course, but the other 50% is from the first parts, first 2/3 of the course. So you have to make sure that it's cumulative and make sure you understand all of what we've gone over, okay? The exam, the exam is the same length, number of questions. I give you a half hour more since it's covering more material, so you'll have 2.5 hours. Okay. Let me review the exam for you of the questions you missed. I'm going to go in the order of what you have on your sheet here, so we'll jump around a little bit. And then I also gave you feedback on questions you didn't submit work that you didn't get right because I want you to understand how to do them all. Okay, question 1 is asking for the domain of this rational function. When you're given a rational function, polynomial divided by a polynomial, all you have to do to work on the domain is to figure out whether the denominator can be 0 ever. Then we just cannot include those points. But you notice that x squared is always positive, or 0 if x is 0. So adding a 0 or a positive number to 6 will always be positive. That can never be 0. So there's no restrictions on the domain here. The domain would be minus infinity to infinity. For question, I couldn't increase your score there because there just wasn't anything I could see on that one. Question 2. I did increase your score from 0 to 0.5 on this one. You did have the denominator factor correctly. So now that gives you everything you need because notice that the numerator x minus 6 could cancel with one of the factors in the denominator. Once you do that, you've changed the function, but that does give you indication that there is a hole. If you can cancel a factor in the denominator that would make it that would have made the denominator 0, that is a hole in your graph. It's not in your domain. There's just a hole there. But this factor x minus 5 tells me that at x equals 5, I have an asymptote because I cannot cancel with anything in the numerator. All right, question 3, I increased your score from 0 to 0.85, and on this one, you simply just did not put in y. So you understood how to find a horizontal asymptote. Just look at the highest powers here, minus 8x and 5x, and then the x's cancel, so your y equals minus 8/5 should be that, and you forgot to put in y equals. Let's see, questions 4 and 5 were fine. Question 6, I increased your score from 0 to 0.33. There wasn't a lot here. Since we're on this, and there wasn't room here, I wanted to show you, so I did add a third page here. When you are solving this kind of inequality, you basically have a fraction. You want that fraction to be positive. So how do I make that fraction positive? Either they're both positive numbers, the numerator is positive and the denominator is positive, or the numerator is negative and the denominator is negative. So these are the two situations you have to work through. So then as you work through them, if the numerator is positive, and it could be 0, right, because it says greater than or equal to 0. If the numerator is positive or 0, that means that x is less than or equal to 2. If the denominator is positive, that means x has to be greater than 4, but that's not possible. You can't have x be both less than 2 and greater than 4. So that's not a solution. So then you check the second situation where they're both negative or 0 in the numerator. That means x has to be greater than or equal to 2. And x has to be less than 4. That's possible. So that is your solution to that inequality equation. Okay, so that was 6. Again, you didn't have that kind of work, so not much I could do. I saw that you were understanding there's issues at 2 and 4, but other than that, I couldn't do much else. All right, number 7. I increased your score from 0.75 to 0.88. Here, you basically, number 7. On these two questions, 7 and 8, you really just had the graph wrong. Everything else looks right. Now, why is this graph wrong? So this should be the exponential function 3x shifted down 5 units. And it looks like you tried to do that, but you were a little bit off. So if 3 to the x, every exponential function, b to the x, if b is greater than 1, will come and pass through the point 0, 1. So when I shift that down 5 units, that's the point 0 minus 4, and you'll notice that you don't have yours there. So it's off a little bit, and that's why I marked it wrong. But you have the asymptote right, and you had the shift down idea right, so I still gave you some credit for that. And the same thing happened in question 8, except you did a good job shifting it. But the problem is you didn't put the asymptote in your answer. so you just had to get the asymptote in your answer. All right. Okay, so that's that deal. Let's go. Let's see, problem 9. So 9, looks like you got 9, 10, 11, 12, 13, 14. Those are all good on your own. So now when we get to 15, 15 you did not answer. This is you just have to understand how to evaluate something like this. So the reason we need to know how to evaluate this is because calculators don't have log of any base. So the way you do that is you evaluate either using the common log, which I did, or the natural log, because calculators have a common log or a natural log button. So you take the log of the number that you're trying to take log base b of, log of 87.5, I'm using base 10, divided by log of the base, log of 15. That's how you evaluate those types of problems with your calculator. So you got to make sure you understand that. Question 16 you had it correct already. Question 17 you didn't, and it's an important one. You just wrote down the problem and then no answer. So how do I do this? If I have functions of x in the exponents, I got to get them out of that. The only way to do that is to take the log of both sides. I use the natural log because most people use the natural log to solve these types of problems. So when you take the natural log of both sides, we use the rule that allows us to bring exponents down. So you bring 2x plus 5 quantity down, and here you bring x minus 3 quantity down. Then it becomes a basic algebra equation where you solve for x. So I won't run through that, but just solve that for x now. And then you get, here's what x is, and then you can plug it into your calculator and get that approximation. Okay, let's see. So let me jump to question 29 because you have that right here on the front page. So when I jump to question 29, so we have, for some reason you were using sine and not cosine. Remember, cosine is adjacent over hypotenuse. So the cosine of 26 degrees is b over 209, right? So b is 209 times the cosine of 26 degrees. So you had the right idea, but you're just using sine versus cosine. So you have to understand what sine is. It's opposite over hypotenuse. Increased your score there from 0 to 0.5. Okay, and that's it on this first page. So now it looks like you started working backwards. So let's look at 28. So 28. So you just have to put these numbers in and evaluate. So you got 2. The tangent of pi over 3 is root 3. That's correct. And then plus cosine of pi over 4 is 1 over root 2. That's correct. Times the tangent of pi over 4, which is 1. So I'm not sure what I'm seeing there, but it's not that 5 halves there. But so it's just 2 times root 3 plus 1 over root 2. So you got to, they don't like root 2 in the denominator, and we got to combine this into one fraction. So 1 over root 2 is the same as root 2 over 2, right? Multiply by root 2 over root 2. Now your common denominator is 2, so you got to get 4 root 3 plus square root of 2 divided by 2, and there's your answer. I increased it from 0 to 0.8 because you did have these guys evaluated correctly. All right, 27. 27 you didn't answer, and you really didn't write much there that I could get credit for. So I just need you to understand this. Where is the angle minus 9 pi over 4? You start on the positive axis and you go positive x-axis, but you go the clockwise direction for a negative angle. If you go all the way around once, that's 2 pi, which would be 8 pi over 4. So that's not far enough. We go another fourth, 1 pi over 4, which is 45 degrees. So you have a 45-90 reference triangle. That side's 1, this side's minus 1 because it's now on the negative y-axis, root 2. So, and then you have to understand that secant is 1 over cosine. You can get what the value is. All right, so 26 you got correct. 25, I changed it. You got it. it marked it as 0, but I gave you full credit on this because you simply had the right answers but didn't rationalize the denominator. That's all. So 25 you did correctly. 24, you didn't really know what they were asking for here, it seems like. So what you have to do is you want an angle that is the same. Essentially, it's coterminal, but it's less than 2 pi. So the way you do that is you just keep subtracting 2 pi from your angle, because that will always bring you back to another coterminal angle until you get an angle that's less than 2 pi itself, which is 5 pi over 4 in this case. Let's see. 23, 21 were fine. 22, 22 on this one, you just made a mistake of forgetting to put in the negative sign. You had the negative sign here and then it fell off. So I went from 0 to 0.95 on that. The negative sign is important, but you had it originally and then somehow it dropped off. All right. 21's fine. 18. 18, I really couldn't increase your score because you weren't showing me that you knew how to do this one. When you have an equation with logarithms in it, what you really want to get to is you want log of something on one side to log of something on the other side. So you want to combine these two logarithms. And the way you do that, if you have log of something plus log of something else, that's the same as log of 6 times this x plus 1. So now you have log of 5x minus 1 equals log of 6 times x plus 1. So those have to be equal. That allows you to solve for x. So it seems like you get a solution of x equals minus 7, but unfortunately that's not a solution, because you have to go back and think about, well, what would x be if I plugged it in here? Then I'm taking the log of minus 36 on the left, and I need the log of minus 6 here, and you're not allowed to take the log of negative numbers, so there is no solution. Okay, 19 and 20, I also wanted to give you feedback on because you didn't have any work for me, and you need to know how to do these. So these are both exponential problems. First one's exponential decay, 20 is exponential growth a little bit. So 19, the exponential growth or decay model is A equals A0 e to the kt. So A0 is your initial amount present, A is how much is present after some time t later. So they tell you at the half-life, in other words, where half-life is, you start with an initial amount and it decreases to half of that amount. So in other words, the amount that you have at the half-life of t equals 39 hours is half of your original, A0 over 2. So you plug that into your equation, the A0's cancel, you get 1/2 equals e to the 39k. This allows us to solve for k. To solve for k, you got to get it out of the exponent, take the natural log of both sides, and you can work through that and see how that works. So now we have k. Then they ask you, well, how long will it take for the drug to get to 94% of the original amount? That means when is A equal to 0.94 of the original amount times A0. So that allows you to solve for t when that happens. You put 0.94 A0 equals A0 e to the k, which we solve for, times t. Now you can do the same thing and solve for t. Likewise, in number 20, you have something similar. Except for in 20, they say we have an exponential growth problem, but we have this nice little tight formula, t equals natural log 2 over k, gives us the time that a population will double in any population. So k here is 0.004, right, e to the kt. That's the growth rate. Now they want you to as a percentage, so how do I turn it to a percentage? I multiply it by 100, moves the decimal over 2, so it's 0.4%. And then how long will it take the country to double its population? You just plug that in. T equals natural log of 2 over k. Now here you use k not as a percentage in the formula, so it's 0.004, and you get 173 years. Okay, so that's your feedback on exam 2. I talked about the final exam and where you stand in the course. If you have any questions, Josh, reach out to me, okay? We just got to bear down for one more week. Hang in there.